rationalizing the denominator means eliminating the radical from the denominator. We are not allowed to have a radical on the bottom of a fraction. We're not allowed to do that. So we want to remove the radical from the bottom of a fraction if it ever shows up. For instance, if I have the square root of 7 over 3, using that quotient property, I can split that into the square root of 7 over the square root of 3. I'm allowed to do that. Now, here's the problem. Neither one of these simplifies. There are no factors of 7 that are perfect squares. There are no factors of 3 that are perfect squares. But I'm not allowed to have this square root of 3 on the bottom of a fraction. So here's what I'm going to do. I'm going to multiply the bottoms of the fractions by the square root, both the top and the bottom of the fraction by the square root of 3. If I multiply both the top and the bottom of the fraction by the square root of 3, I would get 3 times square root of 3 times the square root of 3, and square root of 7 times the square root of 3. Now we've already seen that product property. It says we can mush these things together. So the square root of 3 times the square root of 3 is the square root of 9. The square root of 7 times the square root of 3 is the square root of 21. Now, the square root of 21 doesn't have any large perfect squares. So I can't simplify that. It's just the square root of 21. But the square root of 9 is 3. And I can simplify that radical. So my final answer, after I've rationalized the denominator, is the square root of 21 over 3, because I multiply the top and the bottom by the square root of 3, by whatever is on the bottom.